What you see here in this picture is probably the simplest form of architecture you can imagine. You just have one simple application that can read and write to one single database. Now, what I want to talk about today is distributed databases. In distributed databases, instead of just having one single server with one database, you would have multiple different servers with one database each. On these different databases, you can either spread your data across, so part of your data is in database 1, other part in database 2, and the third part in database 3. You can also have systems where you have the whole database here, and then a complete copy of that in database 2 and a complete copy of that in database 3. And I want to talk a bit about why we need that. So let's say for the first scenario where we spread data out across different nodes or different databases. Well, imagine you have a lot of data. In this particular scenario up here, you just have one single server. At one point, you might have so much data that you simply can't store more data on this particular database. What you can do then is just buy more computing resources. So you can do what's called scaling up. And this can be a good and the right solution to do in some instances. But there are a few problems with it. The first problem is that the bigger the computer is, the more expensive it gets. For instance, it's much more expensive to buy one server with 128 CPUs instead of buying 16 servers with 8 CPUs each, even though the total amount of CPUs is the same. Another problem is that at a certain point, you simply can't make it any bigger. There's a limit to how big servers get. So the way distributed database system actually fix this is that you can have multiple relatively smaller SQL servers where your data is spread out across, but it can handle the same load or more. Scaling this way is called scaling out or horizontal scaling. You can add as many SQL servers and databases as you want to. Another very important reason you might want a distributed database system is to have fault tolerance and ensure high availability. Instead of spreading your data out across the different SQL servers, you could also just have a complete copy of your data on the other servers. In that scenario, you might have one database here in database 1 and exactly the same database and data in both database 2 and database 3. Setup like these are catered towards having really high availability. And what that would mean is that if one of these servers suddenly go down, well, then the system will still work exactly as before. There will just be one less node in the system. In a single node database system up here, if that one node goes down, well, then your whole application will stop working. And that's why having multiple nodes and having multiple replicas of your data can be very good to ensure high availability. And I want to show you this example in practice. So I jumped over to SQL Server Management Studio, where I have different SQL servers installed on my local machine. I want to preface this by saying that usually when you're doing horizontal scaling, you're doing it in cloud environments and not so much on premise. But this is mostly just to exemplify and show the concept of high availability, which you achieve through distributed databases. So as I said, I have installed 3 different SQL servers, or actually they're all the same type of SQL servers on my local machine. This up here is my primary SQL server where I have this company database. I then have these 2 other SQL servers where I have a complete copy of this company database on these SQL servers too. This copy is achieved by something called replication. I have a primary server here, that is this one. And whenever updates are happening on this one, it'll automatically send those updates to the replicated databases by using a transactional replication. The details of this are not that important, but what I actually want to show you is a program. So I want to show you a simple Python program that I wrote. And one thing that you should note here is that I only have one single server specified, localhost 1436. This is where my load balancer is currently sitting. I'm using a HA proxy in my specific cage, but I have only specified one server which it can read from. Now, when I run this particular application, what will happen is it'll just read data from the company database. You will see that this is just different random data that it's reading out. But the important part to notice here is that I also print out what server it's coming from. So this is my primary, this is my instance 2, this is my instance 3. Right now it's doing it in a round robin principle. So it's just switching every time it makes a request to another server. And that is something you can specify in your load balancer, what kind of load balancing algorithm you actually want to use. In my example, I just chose round robin because I want to make it as simple to understand as possible. I also have a interface. I want to show you here that I have an interface for my load balancer where you can currently see that all of my servers are up and running. But what we can do is we can actually try and shut one of them down. Let's say that SQL Server Replica 2 goes down. We can do that by going into services. So here we have my SQL Server instance 3. What I can do is I can simply stop it and simulate that this SQL Server is going down. After that has stopped, we should be able to see inside my my interface here that this replica is now down. It's no longer working. So if we go back to our program to see what that means for it, what we can see is that nothing really happened in the program. It's still running exactly as before, showing the same data as before. The only difference is that now it's only taking data from my primary database and instance 2. It is no longer taking data from SQL instance 3 since that has gone down. We can also try and shut down the primary server here, and we should see that it should still be working even after that. So now we have 2 servers that are going down. We can confirm that by looking in my interface here, refreshing. Now there's only one replica that is left up. And if we go back to my program, what we'll see is it'll still work as before. The only difference is now we're only getting data from SQL instance 2. So this is a proof of high availability. And of course, as soon as we start these servers again, they should start being used in here again so that it keeps this distribution going. So now we're also getting data from my primary once the other SQL server is up and running again. And this is how high availability is achieved through distributed database systems.